I'm Dave Johnston, and I'm here today with Bryant Parker, and I'll let him describe his company and the robot arm that we're going to be showing a demonstration of today. And we'll just start off with Bryant giving a description of what we're seeing here.
Alright, so this is the Universal Robot. It has 3 sizes, UR3, UR5, UR10, with varying load capabilities and varying reach for your different applications. What makes this robot different than others that you'd see out there is that it's a collaborative robot. And there's 3 main points to a collaborative robot. The first being safety. This robot is monitoring current in each joint, and when it detects a force or current coming back due to torque in a direction that it's not expecting, it's able to shut itself off and protect a human or parts if they were to get in the way. So you're able to work side by side with it. So the safety is the first one. Second is ease of programming. This is the teach pendant here that's used to program the robot. It can all be done right here, so a technician can do it. You don't need a robotics engineer or a software engineer to program this guy to get up and running. Then the third is maintenance. Each joint has an integrated servo drive motor. So with that, you're able to very easily pull the motor and drive out, removing this cap and putting it back in, and then sending the signal up from the controller telling it which joint it is. So it's a very quick replacement and very quick to get back up and running. You don't have to send this out to the factory. Your technicians can do this. So those are the 3 points. This is a 6-axis robot. Each joint, like I said, has a integrated servo motor with a 100-to-1 harmonic gearbox. This allows for each of them to have no backlash, and your repeatability at your tool center point is plus or minus 4 thou. So you can get very good accuracy, and you're able to teach this.
Bryant, what do you do with respect to safety, or how do you react or interact with the arm to always be safe?
So within the programming, it's, like I said, it's constantly monitoring the current. And so you're able to monitor and see exactly, I don't know how well they can see that, but as I pull on these joints,
so all of these different movements here,
you can see the current being monitored.
So each one of these, this is the top one, the base joint, and then they go down out to the end gripper?
Okay. Yeah, so you've got each joint, 6 of the lines, and so you're seeing the current coming back on each of those as I pull and tug on them. So, if we were to do a quick program just to show the safety and the programmability, I can come into the teach screen, and I can go to structure, and it's all tabular. So you can come in and select a move, and it's going to populate over here. You've got 3 different options for a move. You've got a move J, you've got a move L, and a move P. This stands for joint, line, and process. So with a move J, you're going to get from point A to point B in the most efficient way possible. The robot plans, that trajectory. Then you've got move L, which is straight line from point A to point B. And then with move P, or move process, you're able to do straight lines or circles, but you're able to do them at a constant velocity. So this is for your gluing, dispensing, welding, different applications like that, where you have to be moving at a constant velocity. That's where this would come in handy, is that you're able to do those and have a constant beat of glue, weld joint, or even drilling into something, you have a constant feed rate into that part. So I selected just move J, and then we can come in and we can select waypoints. If I come over to the command screen and I select set this waypoint, then I am able to either use the screen here, or on the back of the robot there's a teach button. Once I hold that down, I'm able to move the robot wherever I want.
Oh, I like that a lot.
So it's monitoring the current. So with 101 gearboxes, if this was not to be engaged, it'd be very hard to backdrive those. So what you're doing is you're actually guiding the robot, and it is seeing those currents on that log screen like I showed you before, and it's allowing you to move. So just to set the points, so we'll come down here and we'll say That's our first point.
Now, before you do that, can I come and move it? There isn't a safety issue. The robot's safe as far as a person interacting with it like you just did. There's no worries where a person has to take special precautions as you're working with it?
No, as you're working with it.
So if I grab it and move it.
So once I push that teach button down, yeah, now you can.
Oh, I see. Okay.
So now you can move it.
That's awesome. Okay.
So you're able to move it wherever you want. There's not a safety where it's gonna come and run into you or do anything like that. But also along the lines of safety, we'll, let's say we go there, set the first point, we add a point after, we set this waypoint, and we'll just come and bring it over here. So now we hit OK. We hit play to start these 2 points. We're going to show how easy it is. So it's got a safety feature where it's going to move back to its initial point. This is because the robot does not have, it doesn't know if there's something in the way here. So to start from the last point, it doesn't know, it basically on this screen it's saying, hey, will you move me back to start so I don't hit something on accident. So we move it back to start, we press play, now the robot's moving to those 2 points we taught. Now if I come in here and I put my arm here and bump it, the robot stops. It goes into protective stop mode here, basically saying, hey, I ran into something, I need you to say it's okay to keep moving. I come in, I say okay. It also logs this on your log screen, showing that there was a safety error. I press play, and it goes right back into its function. So now it's able to move back and forth. And I move the table slightly on that.
Yeah, we don't have the best table set up here, given we're using the kitchen table, so bear with us on that.
Yeah, no problem. So you saw again, I grabbed this, it stopped. So with that, you can see that working side by side with the human, if it hits the human, it's going to stop. And there's varying levels of control. If I come into the installation, I'll move this guy out of the way. If I come into the installation, go to safety, you can actually see that there's you can scroll along here and decide how much it takes to set that robot off. From very little, down around the 25 Newton range, up to the 125, 150 range. So you've got some control on when that will trigger. And that just kind of depends on your application, on what you're doing. Each time you install a robot, you will fill out a risk assessment. And this will allow you certification. So when OSHA comes in, you show them the document and it lists any safety concerns. It shows that the robot is capable of stopping and you're good to go.
Bryant, what can you show us that kind of goes to the extremes of the degrees of freedom, keeping in mind the limitation that we're strapped to a kitchen table here, how you can make it flow, make it move around or move it quickly or whatnot?
So let's teach a couple of points here. So I'll teach that one there, and then we'll come down to this here, and we'll come and we'll do this here, and we'll come like this and go there. Now what I will do is, inside of your move, you've got your accelerations and speeds. So what I'll do is I'll bump this up to the max speed, and I will do about 1/3 of the acceleration, and we'll move it up and you'll see it increase. If you go all the way to the top acceleration, you have to start curving the radiuses between points so that you don't get a jerk, because it could fault the robot feeling that impulse of that change in motion. So we'll go to there. So So we'll press play, move it back to its start position. You can see it moving.
Is this repeating? Oh, that was the one cycle.
Yeah, that's just the one cycle. Those 4 points, it'll just cycle through.
Okay, say it again. This what was this with respect to what the arm is capable of?
So this was max. This was max speed, but 1/3 acceleration. So really, it's not reaching its max speed.
Okay.
As we'll increase the acceleration, you'll see. Another thing that I'm going to do is, like I was saying on the safety settings, you can have varying levels. Right now it's at second from the bottom. So what I'm going to do is I'm actually going to put the safety settings to the highest. So we'll come here, or I guess I should say the least sensitive. So as I do that, every time you change the safety settings, you heard the brakes engage. I have to restart it to apply those safety settings. So you'll hear the machine starting back up. I'll come back to the initialization screen. Turns on the controller first. And then you can hear all the brakes disengaging, ready for motion. Okay. So
and when you just a note, when you see the arm wiggle like that as brakes change, that's not because of the arm, that's because of our cable and how we're just jury-rigging this for this demonstration.
So I guess so that's true, but there is a little bit of wiggle because each joint has 2 encoders. It has an absolute and an incremental. And so that little wiggle right at the beginning is the incremental lining up with the absolute.
Okay.
So there's a little bit of wiggle aligning those, but yeah,
the big wiggle is the table.
The big wiggle, yes, correct, is the table. So anyway, so we decreased the safe setting, meaning it's less sensitive, so now it's able to go at a higher speed.
This is going to be faster speed, but how much with respect to what the arm's capable of?
So the arm is capable of up to 192 degrees per second, and then it's able to go up to 3,000 degrees per second squared. Roughly that translates to about 1 meter per second in linear distance. So right now we have max speed, 192 degrees per second, and we have 1,200 degrees per second squared. So about half, almost half the acceleration. Actually, we'll just do half. Let's say 1,500. So half acceleration, full speed. This is what we'll get. So we'll press play. It will ask us to move it to its start position, like before. And I'm going to hold the table because it's going to rock it. I'll press play. Okay, and press stop. So you can get going very quickly with it, and some very good speeds. And you just kind of range on how quick you can go with your application.
Now, if we wanted to pick something up, I can set it there. You could then program it to use the gripper, come pick it up, move it around, set it back down. Is that right? With
yes.
Setup? Okay.
Yes. So
we've got the board here, the AggressiveFun.com logo board, and we'll play with that a little bit. See if it can just pick it up, maybe rotate it a little bit, and then put it down in another spot.
Yep. So what I'm going to do real quick is, right here on the end there's a robotic gripper. That's what we've got hooked on the end here.
These are kind of soft, yeah.
They got some soft. It should be okay.
Okay.
You're not too attached to that, right? If it squishes it.
Yeah, it's fine. It's robust. It'll be strong.
It'll be strong. All right. So what Robotique has done is they've done handshaking with Unversal Robot into where their products are controlled on screen. So I'm able to actually turn on the gripper here, and I can open and close it using the same teach pendant. It doesn't require an external controller. as well as there's templates that I can pull in. So I'll come in and I'll open the basic template, and it's going to ask me to load the configuration. I'll hit OK, and we'll just boot it back up because it wants that on there.
So with the clicking, it locked into place while you are going to do other adjustments, and then it will unlock when you're ready to move again.
Exactly. I mean, basically inside the installation file that was with their template, the safety settings changed. So because of that, it required those to be put into place and ran, and so it has to restart.
Gotcha.
So now we're ready to go. So now we have all of the sub-programs to call this gripper. And now we'll come in and we'll just do a quick move, and I would say it's it right there. There's our first point, and then I'm going to say, alright, for our next point I'm actually going to use the move screen, and you're able to move along the tool axis. So I'll just come down. We'll set that right there. And I'll close the gripper just to test. Okay. So we are good. So then after that, so I will hit OK there. After that, I'll just come in here and say, okay, waypoint 1, rather than trying to teach that again, I'm just going to come in here and say, copy that point, paste that point after that. So now we've got an up, down, up motion, and then set another point here, add another waypoint. We'll grab this guy and we'll just say twist it 90 degrees and set it back down. And we'll hit, set that point, we'll hit OK. So now we're going to open the gripper up, and we will move to our initial point. And we'll orient that back to this, and we'll hit play. One caveat, I need to call the sub-program for that. So inside of here you have advanced functions where you can call sub-programs that are embedded inside of your software. So I'll call the sub-program, and now after waypoint 3 I will call the other program for the gripper to open. It will initialize, come down, grab it, bring it up, rotate it, open it.
Perfect.
So
that was slick.
Very easy
Now,
program.
let's do a close-up of that.
Of the gripper?
Yeah, run the gripper.
I'll press play. So just a slight little bit. Okay.
Very good. That concludes our demo of the robot arm. I appreciate Bryant coming in and showing us how it works. Hopefully you got some useful information out of it. Very cool robotics. Especially love the positioning capability. So thanks, Bryant. Thank you. Appreciate it.